All right, Algebra 2. Guys, welcome back. All right, we are jumping into Section 6 today, Chapter 6, Section 6. It's the fundamental theorem of algebra. And I'm telling you right now, pay close attention. All right, Section 6 is the real deal. This is not something that you want to stop or pause as much as right now you hear me saying that, and you're like, I'm not ready for this. Get ready. All right, have your book open. I'm going to follow through with this. Everything you'll need to know, step by step, but you need to pay close attention. All right, so stick with me. Here we go. All right, everything there on the page, that's the basics. All right, that's the basics when it comes to as far as like your definitions. All right, so you're going to be given zeros, and by that I mean that you're going to be given either the roots or the zeros, and that's up to this point basically been our answers. Okay, so you've been given this big polynomial, and then they're going to say solve it, and you might have to factor it. You may eventually have to use the quadratic, all those things, and then you just get down to having your answers. But up to this point, that's all we've known. Now they're just going to give you the numbers, and you have to go backwards. And you're going to go backwards, and your answer is then going to be this big polynomial when all you started out with was a few numbers. Okay? So our first little definition here, you're given the zeros or the roots, and you're going to go backwards. All right? So you're going to have much bigger polynomials as your answer, rather than having these nice, simple, tiny little polynomials. Okay, so there's a little example little example problem that I gave you right here. And so if you were given these values, 2, -4, 3, if those are the values they give you, and then they're going to say, okay, create the polynomial that has these roots, otherwise known as zeros, that means if you graph the polynomial, these are the x values where it will cross at the x-axis. Okay, so let's go backwards. 2, in terms of a binomial, would be represented by this right here, x minus 2. Because if you had x minus 2 and you solved it, you'd get 2. All right, and then a -4 would be represented right here as x plus 4. So we're doing the opposites. And then 3 would then be represented right here with x minus 3. Okay, as I said, follow along real close, guys. Pay attention to these example problems. Here we go. All right, so write the simplest, so the most basic possible polynomial from the given zeros. All right, so step 1 is taking the given zeros and converting them into binomials. All right, so let's zoom in, get a little bit more space when we zoom in here. So for the -2, this is just going to be x plus 2. For the +2, this is going to be x minus 2. And for the +4, this is going to be x minus 4. Okay, simple enough. We start now with 3 binomials. And with this first little intro problem, what you are doing is you will then be multiplying all 3 of these binomials together. Okay, so let's just start by multiplying these 2 together, getting a polynomial, and then multiplying this last binomial into it. Okay, so if we multiply these first 2 binomials, x plus 2, x minus 2, it's the same thing as FOIL. All right, so you have x times x, x times -2, then you're going to have 2 times x, and 2 times a -2. All right, when you do all of that, you're going to get x squared minus 2x plus 2x minus 4. These guys right here in the middle cross out because you have a -2 and a +2, so they're gone. So what you're left with then is just x squared minus 4. Let's put that back in parentheses and then multiply it now by the x minus 4. That's the final binomial that we haven't distributed in. And then we're just going to take our terms and do the same thing. There's x squared times x, then times negative 4 times x, and negative 4 times negative 4. Okay, so you work that all the way through, and you're going to then get x to the third minus 4x squared minus a 4x plus a 16. And this is as far as we can go. That right there is in that perfect descending order of exponents, and everything has been as simplified as possible. Okay, so if we kind of zoom out right there, you see again, we started with just the 3 number values, the 3 roots, the 3 zeros, and we had to go backwards and create the polynomial that would make those roots. Okay, next one. Same style. Okay, so you'll see one more of these guys. All right, and we have 0, 2/3, and then just 3. Okay, so the nice thing with 0 is this is just x. That's it. So there's no plus or minus something. Okay, the 2/3, that's going to be x minus 2/3. There's the binomial for that. And then for 3, it is x minus 3. Okay, so now what we're going to do is let's go ahead and distribute using our binomials. Okay, and then we're going to do this side over here and see what that creates. When we use FOIL, you distribute all the way through. Then you're going to get x squared minus 3x minus 2/3 x plus 2. And now let's go ahead and simplify our terms here. So that's going to give us x squared minus 11/3 x. All right, so that's taking 3 and subtracting 2/3. All right, and then plus 2. Okay, and now don't forget we have this x value that we need to put here, and then distribute this x value into everything so that we have a final simplified answer. And that's going to give us now x to the 3rd power minus 11/3 x squared plus 2x. All right, so there we go. Oh, that did not work out. Let's just keep it. There we go. So when you distribute that x in as your final step, you'll notice that really all you're doing is just upping those exponents by 1. There was nothing really special that needed to be done there. Okay, so going to zoom out a little bit. You can see the steps, right? These are the basic intro steps to these problems. All right, so now let's do this next one. So now we're solving, but you're going to see how many terms do we have here? 1, 2, 3, 4, 5 terms. And up to this point, you've really only solved polynomials with 4 terms, where you could use factor by grouping. We haven't really worked with a 5-term polynomial, and you can't factor anything out that magically turns it into a 4-term polynomial. So we have to take it as is. Okay, so your very first step actually is graph this. All right, use your graphing calculator and graph this. All right, so I'm going to write that off to the side. Okay, graph. This is your first step. And the purpose of this is you need to find the real roots, because unfortunately there could be imaginary roots or complex roots that you don't just see from the graph. So we need to find the real roots that are easy to see crossing the x-axis. Okay, so graph it to find the real roots. Okay, and go ahead and do that. I'm going to save you the time. I graphed it, and you're going to have roots at a -5 and a +1. Okay, so these are the two real roots that you're going to see from the graph when you use your graphing calculator. Now we got to go and use these values. Okay, so we have to use the -5 and we have to use the +1. And now we're going to do this. We're going to use synthetic division. With the real roots. Okay, so that's the whole purpose of graphing it. So now let's move over here and let's do our synthetic division. Let's start with the -5, and then we're going to use the +1. Okay, so there we go. So we got our -5. Our coefficients, we have 1, 4, -1, 16, and a -20. All right, the 1 drops straight down. Let's start to fill in our values here using our synthetic division. Just trying to save you guys some time. So I know I'm filling these in. Might be a little bit quicker than you'd like, but the whole purpose here is, 1, saving time, and 2, you should know how to do synthetic division by now. Okay, so if you don't, you got to be asking questions in class. So what we just created is, 1, we can create a new polynomial, but 2, you can see that this zeroed out. That's good. All right, that means there's no remainder, some weird number that we're gonna have to deal with. We don't have that. So let's write the polynomial that we just created from the first round of synthetic division. So we have x to the power of 3 minus x squared plus 4x minus 4. So that's the new polynomial. And now we're going to have another round of synthetic division where we use the number 1. All right, so we have the number 1. Now we're going to use this polynomial right here, again with synthetic division. So let's write our coefficients. We have 1, -1, +4, -4. And let's go through our steps. All right, first one drops down. Going to put a 1 there, zeros out. Got a 0 here, a 4. Bring the 4 up, and boom, we have another perfect zeroed out synthetic division. Don't forget, I know I didn't put my little add in parentheses here, but you're using addition the whole time throughout that whole synthetic division part there. All right, so now we have another polynomial that we just created. So let's go ahead and write this polynomial from the synthetic division that we just completed. So we now created x squared plus 4. And now we need to solve this. All right. This is why we did all of the work up above, is because we are actually going to be creating a complex root with an imaginary number. And so you would not get that by just looking at a graph on your graphing calculator. That's why we got to do all these steps. Okay, so now we have to solve this. So make this x squared plus 4 equal to 0. All right, subtract 4. X squared equals a -4. So then you are looking at needing to take the square root And you know that taking the square root of a negative, that's going to incorporate I, the imaginary number. So x will equal a plus or minus 2I. It will also equal the values that we got right at the beginning, -5 and 1, because those are the real roots. And then we had to use synthetic division to get the complex roots. All right, so we have our values of plus or minus 2I, and then -5, and also +1. Those are our answers there. Okay, so here's kind of the breakdown, that whole problem right there. There we go, fits nicely onto the page. Okay, so let's do our final problem, which takes some time. So here we go. Simplest polynomial that we can write, but here's, here's the kicker. We are given complex roots, 2I. We are also given radicals with that 1 plus radical 2, and then of course the nice great just regular number 3. Now, here's the thing. With complex numbers and with radicals, you must use the conjugate. And you need to remember, what is the conjugate? The conjugate is when you are taking the positive and the negative of both options. Okay, and I'm going to write this all down for you so you can see you can't just do, like, this is the really simple one, right? Take a look at the number 3. All that is just x minus 3, and we have our binomial that we will eventually be working with. But oh, that was great. That was so easy. But here's what I mean when I say the conjugate. All right, so what does 2I become? You got to break the 2I down into x minus 2I and x plus 2I. That's what I mean by that, okay? And then what do I mean by the conjugate of the 1 plus radical 2? All right, well, here's what I mean by that. This one has even more involved, because notice there's no way of separating the 1 plus radical 2. They're bonded together by that plus sign. So we're going to actually have to even use brackets for this one. You have x plus parentheses 1 plus radical 2 in the bracket. And then we're going to have another bracket where we do an x minus, oh, sorry, one thing I just noticed here. That should be a minus sign. My fault. Do not want to have a mistake early on. All right. And then we have our parentheses 1 minus radical 2, close parentheses, close bracket. Okay. So now what we did is we just set up our binomials. Okay. But you can see with these guys right here and these guys right here, we have to simplify those before we can even move on. Okay. So here is what this, here's what this simplifies to. All right. I'm going to, again, try to save you guys a little bit of time. With this right here, we did this in the last chapter. Okay. So rather than show you every little tiny step, I'm going to go and show you what this will simplify to. All right. This will simplify into x squared plus 4. And this is kind of nice because if you imagine, I know I'm going to go up a little bit. Let's go back to that last problem real quick. You see how we had x squared plus 4 and it equaled plus or minus 2i? You can imagine it's the same thing, right? We're just showing the binomials. Here's your plus or minus 2i. Plus or minus 2i, where'd it come from? Right here, the x squared plus 4. So I'm just kind of showing you both directions that this works in. All right. Now, this is fun. Fun, isn't it? All right, now we have to take the radical, and we're now going to have to perform some steps with simplifying by distributing a negative sign into here, here, and then separately into here and here. And I'm going to show you what that works out to be right down here. Okay, so what we have now is x minus 1 minus radical 2, and then x minus 1 plus radical 2. Now we got another step, because now we need to take these polynomials and distribute everything amongst themselves. So we need to take the x over here, over here, over here. Need to have the 1 right here, right here, right here, and the radical 2. So again, I know I'm kind of showing you this quickly, but I just need you to see everything on the left is going to distribute into everything on the right. That's what all of that jumbled mess looks like with those x's. Okay, so when you do that, here's what you're looking at. Let's go ahead and write this out. You're going to get x squared minus x plus a radical 2x, then minus x plus 1 minus radical 2 minus radical 2x plus radical 2, finally now minus 2. All of what I just showed you is what it would work out if you distribute everything on the left into everything on the right. With this right here, this is what it will work out to be. Okay, now we need to combine like terms. We need to cut out the terms that cross each other out. And this will now drop down, and I'll show you what that looks like. Okay, all of this crazy mess that you're looking at right here will simplify down into this x squared minus 2x minus 1. Unbelievable, right? Okay, so if you take a look at this, your x squared have nothing to go with, so it drops straight down. Okay, now we had minus x became right there our negative 2x. Positive radical 2x, negative radical 2x, so they would cross each other out. All right, then you have a negative radical 2, positive radical 2, they would cross each other out. The nice thing there, the radicals disappear. Okay, then you have a negative 2 and you have a positive 1, combining them together to equal your negative 1. All right, now don't forget, let's zoom out a little bit. This guy is now going to go right here. So now we need to reincorporate all the pieces. And then this x minus 3 travels down here, and it's going to go here, x minus 3. Okay, now all of this now has to be combined together. All right, the fun continues, guys. Let's just keep this flowing. All right, so I'm sure you have a lot of other words you'd rather use than fun right now, but here we go. So we got to distribute everything on this side into here. I'm going to incorporate the x minus 3 at the end. All right, you can't do all 3 polynomials at once. Okay, so x squared here, here, and here. The positive 4 here, here, and here. Now, when you do that, this is the polynomial you will be creating. You're going to have x to the power of 4 minus 2x to the power of 3 minus x squared plus 4x squared minus 8x minus 4. Close parenthesis. Then bring this guy down here, x minus 3, and you're going to do it all over again, okay? But it might be a little bit easier to think if you were to say take these two terms and distribute them into all of these right here. Do that. X distributed here, 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 and here. Then negative 3 distributed throughout the entire polynomial. Okay? When you do that, here is, again, I'm showing you every step so you can see everything I'm doing. Here is the massive polynomial that you will create. All right, we have x to the power of 5 minus 3x to the 4th minus 2x to the 4th plus 6x to the 3rd minus x to the 3rd plus 3x squared plus 4x to the 3rd minus 12x squared minus 8x squared plus 24x minus 4x plus 12. My goodness. Wow. Okay. Take this crazy, insane polynomial and simplify it. Break it down into what you have left. After you simplify, combine like terms, cross out some stuff, you will then get x to the power of 5 minus 5x to the power of 4 plus 9x to the power of 3 minus 17x squared plus 20x plus 12. Wow, right there is your final answer. Okay, guys, that's a lot of info, I know. And if you stuck with me, guys, I'm giving you just the biggest thumbs up. Air 5, thank you for the hard work, the effort, being diligent, and just keeping up. Okay? All right. So let's zoom out so you can kind of see what we're dealing with this whole process, right? The simplified polynomial. And here's everything. I zoomed in so you could kind of get that full view right there on the page. All right, I'm going to leave you with that. Good effort, good work. I will see you guys in the next one.